Okay? Just follow that.
So where'd you get the square root of 1 minus x?
That?
Yeah.
That's 1. As x goes to 0?
No, I mean from the bottom. Like we went from 1 over.
To the infinity?
No, no. Before that. Pre that.
Where I get this?
Yeah.
This derivative.
You took that derivative, which gave you 1 over 1 minus x squared. And you
Well, that was just this little bit on the end of that derivative.
Yeah.
That was just to complete the chain rule.
Okay.
This little bit here was just to complete the chain rule on this whole thing. So you take this piece, right, times this piece ended up being just this. So this and this together produce that result. And that is the new denominator.
Where did you get the 1 minus x? Because it was x by itself originally.
This?
Yeah. Just that top
This
one.
thing.
Oh, you flipped it or something?
Yeah, because negative exponent. Boom. It's got a 1/2 on it, so radicals. No? It's not the easiest thing to see. Just work through it on your own. You know? Work through that derivative. Yeah.
Is it possible that we can get one as hard as this one?
Oh yeah. Yeah, you should be able to, yeah. Am I saying this is the simplest problem in the base? No, certainly not. It's not simple. But it's certainly within your capability, no doubt.
Would it be better to multiply by x in the first?
You say shove this up here.
In the first. Yes.
Multiply top and bottom of your decks. You can do that. Yeah. Matter of fact, what I would have done was I would have had x be up here with this piece. So now I would take the product of your x times sine x equals 0. So I take the product rule up there, and then just take the derivative root of 1 minus x down here. Do it like that. That's probably what I've done. No, it's all good. Well, they work out the same. Alright, that one was a little trickier. So you okay with indeterminate products? How to change them to indeterminate quotients and apply L'Hopital's. Indeterminate differences.
And now on the test, will you tell us which one you want us to do for each one of the forms? So
You have to recognize the form.
Okay.
Yeah. You have to recognize the form, whether it's a product, you know, multiplied together or whatever. Or a difference in this case, the next one. So indeterminate difference means it's subtraction. So the only not comprehensible subtraction that could occur is an infinity minus infinity. That's what's going to happen, right? In a case like that. So what people usually think is, if you have infinity minus infinity case, the answer should be 0. So it's not necessarily true, because it depends on the speed at which these things change towards infinity. Sometimes it's 0, cancel out completely. Sometimes it's some other finite value, right, that they converge to. And sometimes it's infinity, one or the other. So we'll see here what we have. We'll take the first one they have here, 35. The limit of cot x minus 1 on x. As x goes towards, from the right. From the, yeah, from the right. Here's the first example of an indeterminate difference. So first of all, make sure it really is 1. Right? Just because you see a difference doesn't mean anything. This is heading towards 5, this is heading towards 4, the answer is 1, right? So it's heading towards infinity, there's something to talk about. So what is cot x as x goes towards 0? Well, it's 1 over tan, and tan of 0 is what? 0. Tan of 0 is 0. So 1 over 0 is an infinity case, right? So the first one is heading towards infinity. The second one obviously is, right? Okay. So we do have an infinity minus infinity case, an indeterminate difference. We now need to change it into what?
A difference quotient?
And just an indeterminate quotient. We just need a quotient. Just give me some quotient this thing can be written as. Make sure it's an indeterminate quotient.
Over x.
Say again.
Cotangent of x over x. Or cotangent of x.
Isn't it 1 over 10?
Don't you have to make the denominators the
Cotangent
same?
of x minus 1 over x squared over x, I mean.
X
Are you saying this?
X.
makes it a quotient, right? Just giving them the same denominator. That's all we did in this case. Nothing too fancy. So, but you want to make sure, is it really an indeterminate quotient now? Well, the bottom's heading towards 0, so that means the top needs to head towards 0. Is the top heading towards 0?
Is it -1?
Would the zeros cancel out? Like, would it be 1 over 0 times 0, so the zeros would cancel out? You can't do that.
Can't say that.
Will be undefined
Well, no.
because you have a 0 at the bottom.
What is x cot x doing?
It's zeroing itself out.
Zero.
It's what?
Zero.
How do you know?
Zero at the top,
Well, it's
the other
0
zero at
times
the
infinity.
bottom.
So it's
What?
undefined.
No, forget this problem. If I just gave you x cot x as x heads towards 0, what's your answer?
0.
How do you know?
No matter what.
0 times
Zero.
X,
Zero.
that means 0.
Yeah, but then
0
what
times
is
anything is 0.
0 times anything is 0?
Yeah.
What if it's not a finite value?
It's
I understand
still
0 times any number is 0.
But it would still be.
Would you
But
use
what's cot x heading towards?
Would we use the product rule to, like, or is this like the chain rule where we have to like do something inside of something?
Correct. It's not
So-
a chain rule, but yeah, you did do something inside.
So it's like you would use a product rule to set that up as a.
Not product rule, but yeah, it is a product.
So would you set that up as a quotient then? I mean, an indeterminate quotient. And then you
if
have.
you were going, here's the issue. You do not know what x cot x is, right? You think you do because this part's 0, but this part is not a finite value. This is infinity. We just discussed that a moment ago, right?
0 to x.
Correct?
Yeah.
So what's the 0 times infinity case?
X.
It's indeterminate, right? Indeterminate. You got to figure out what this is doing. Right now, you suspect it's heading towards 1. That's what you suspect, right?
You would change it to x over tan of x,
Okay, let's do that.
and then
So
once.
we're now going to take the limit of this little piece in here. We need to know what that is doing. And we do not know right now what it's doing until we apply the indeterminate form for a product. So x cot x, you want to say, write it as x on tan. This is a good idea.
And then from there you'd have to take the
Now,
derivative.
it's 0 case.
Yeah.
So therefore,
So
according to
one-
L'Hopital's rule, I can say this is the same as the limit of 1 over secant squared. As x goes to 0 from the right, and this is 1. Right? So now we know what? We know that
One.
this is an indeterminate quotient. Because this is heading towards 1, 1 minus 1 is 0, the bottom's heading towards 0. So now we know we can apply L'Hopital's rule to the larger scenario here. Lee? Got that, right? You got that, yeah? Oh, yeah. Okay. So a little prelim work based on indeterminate products tells us that we can do something here. Okay. So apply L'Hopital's rule. It is a 0 over 0 case. So this equals, according to L'Hopital's rule, the limit as x goes to 0 from the right of, and you take the derivative of x cot x. The minus 1 goes to 0. I need the derivative of x cot x. So first times the derivative of the second. What's the derivative of cot x? Negative cosecant cotan, right? Ooh, I messed that up, didn't I? Negative cosecant squared, sorry. Ah, I'm embarrassed now. Negative cosecant squared x minus the second